And now I'd love to introduce our speaker, Travis Richardson, who is President and Chief Product Officer at Flywheel. Mr. Richardson has over 30 years of business and technical leadership expertise, and his experience is in data management and application integration solutions. His passion is developing innovative technology that provides real-world impact. Mr. Richardson spends his days with Flywheel users to constantly innovate what the platform can do and set the direction of the Flywheel solution. Today, he will be presenting on the open features of the Flywheel platform that enable reuse and reproducibility. Travis?
Great, thank you, Esther. Hopefully you guys can hear me okay. So today's presentation is really on open science in the context of our platform Flywheel. And, just to, give everybody some orientation, Flywheel is a commercial solution for research data management. And we chose to take that approach primarily just so that we could ensure the sustainability and scalability of the platform. And sometimes people confuse our being a commercial entity with sort of somehow being closed and not committed to open science. And that couldn't be further from the truth. So what I'm hoping to do today is to share with you all the various ways we address and support open science. And to start with, just a little background on what Flywheel is. It's a software platform for collaborative scientific research. It's an informatics platform and using fancier terms. And our specialty is around imaging. We started at Stanford University in an imaging core facility there, where the idea was, data sets are getting bigger and more complex, algorithms and processing pipelines are getting more complex, and there are many more opportunities to collaborate across teams. And Stanford built a predecessor to Flywheel, and it was very popular. And the idea for scaling a solution and taking that to market to help with additional use cases was born. But basically, it's software, can run in the cloud, can run in your institution and your kind of private cloud on-premise infrastructure. And our customers use us for imaging research, brain mapping type research, human connectome pipelines, that type of work. Increasingly machine learning, because the same workflow and collaboration process is relevant in preparing data for machine learning. And because we're web-based and secure and easy to use, we see ourselves involved in many multi-center studies and clinical trials. And at a super high level, you can kind of think of Flywheel as a way to capture and ingest your data. A big part of that is the de-identification process. So we help with automating various aspects of de-identification, so you can reduce the data privacy risk, to meet the requirements of your IRB. But the heart of the system is a metadata repository to keep track of all your files and assets and images and how your workflow is progressing. And I'll go into a little more detail on some of these things in a minute. And then to support the metadata and operation and workflow in your system, we have a computational framework. So we have plug-in workflows, container-based applications that are typically, things like your common open source tools like FreeSurfer and FSL and SPM and ANTS and MRTrix and other things. But it can also be your own pipelines. The human connectome pipelines, by the way, are in there. And we also have a totally open framework for accessing Flywheel from all your favorite scientific languages, Python, MATLAB, and R, and so on. And then everything is done in secure project context, so you kind of meet your IRB requirements, and we make it easy for you to collaborate, not only in the building, but with other institutions you might be working with. So that's the high level of Flywheel. We're deployed at roughly 40 or so top tier institutions around the world in many different ways. So our customers range from academic, clinical, and commercial. So imaging core facilities, large imaging research labs, doing multi-center studies or other NIH-funded projects. Our customers increasingly are in clinical research, taking data from the PACS or the VNA systems and de-identifying that data to support research and machine learning. And our largest customers are actually on the commercial side, doing precision care and AI work, as well as clinical trials to drive R&D efficiency. But regardless of what the customer is, the workflow is basically the same, and it's very much an open science based approach. So at a higher level, Flywheel is there to help the project teams, the labs work efficiently, with gaining productivity, collaborate more effectively, but also to work in an open and flexible way to meet, so they can, we're not trying to tell you how to do your science. So we want to make sure you have the flexibility to do whatever you need to do. And a big focus of Flywheel has always been support for reproducibility. And so I'll touch base, given that open science is largely about the openness and flexibility and reproducibility on one side, I'm going to emphasize those two aspects. And then broadly from an institutional point of view, reuse is also of interest, sharing data, building on the data, getting more value out of the same data. And that's a big focus. And in addition to, important things like, scalability, security, privacy, and compliance. So I'm going to emphasize really the openness, the reproducibility, and the reuse aspects in this presentation today. And feel free to interrupt me along the way if you have questions, or issue a question through the chat and or the Q&A feature of Zoom, and the team will interrupt me as needed. But if we get into the open science world, you can kind of think of the three key areas that I just described as let's start with open and extensibility. There's many ways we do this. We have open APIs for everything. We have language bindings for all the major scientific languages. Everything is designed for extensibility. I'll touch on a variety of ways we do that. And we have a great deal of our platform is open source. Not entirely, and I'll explain that as we get into it. But for the most part, anything that touches data is totally within your control and is open source. On the sharing and reuse side, this is a fundamental element of collaboration and obviously open science principles. So we'll talk a little bit about data sharing and algorithm sharing. We have an exchange of open source algorithms that can be plugged into Flywheel, so that we make it easy for you to run your common pipelines and anything that you want to do on a routine basis. And you'll also see, we'll discuss the fact that we have comprehensive bid support in the platform. So we're a big believer in bids, and are actively supporting that. And I'll give you more detail on exactly how we do that. And then reproducibility is a fundamental principle of Flywheel. And we'll talk about not only the notion of how you reproduce a project end to end, but some details around reproducible components and how we track things from a provenance point of view. So this is just sort of a high level survey. Now what I'm going to do is just kind of walk you through some of the key areas and how we apply open science principles in Flywheel. So again, let's take a little bit of a deeper dive into the openness and extensibility of the platform. So as I mentioned just a minute ago, the first thing about Flywheel is while we're a commercial solution, we publish all of our APIs. So this is done literally using Open API, which is a spec for specifying REST-based APIs. So it's in a Swagger hub kind of thing, for example. So every endpoint in our system is exposed in this way, and all of our internal tools use the same API. So we don't have private APIs, backdoor kinds of things. We literally publish everything. So our web user interface, so we have a nice, easy to use, graphical user interface for managing your data. But we also have automated connectors that connect to your scanner, your PACS, that type of thing. They use the same API. We have powerful command line tools for scripting and scheduling jobs and importing and exporting bulk data. Those all use the same API. And then we provide language bindings for MATLAB, Python, and R, which seem to be the most common languages. In fact, soon we'll have a JavaScript version of this that's generally available. But the heart of the Flywheel system is a metadata database, and then we format data to support very powerful searches, and we also help you with your compute management. And again, all of those services in terms of how you store data, how you manage data, compute against data, and so on, are all published through these open APIs. And we integrate with your security systems via open standards as well. So another way that this turns in, that Flywheel supports open computational workflows and sharing of algorithms is through a concept we call gears. So a gear is a reusable component, and it's a reproducible component that is ultimately based on Docker or OCI, Open Container Initiative compliant containers. So if you can get your algorithm running in a container, Flywheel can manage it and help you execute it either on batch, on demand by pointing to a data set and running it, or by gear rules that are activated as new data arrive or state changes occur in your database. So you can automate a workflow in a population study to ensure that everything is done consistently and so on. With the same level of, same parameters, same quality, all that kind of thing. And one aspect of that is the fact that we just containerize these applications and give you a framework for plugging them in. And then Flywheel can orchestrate everything, and including things like on the right here, being able to elastically scale your runtimes. Let's say you have to do 1,000 free surfer jobs. Flywheel can, in the cloud, can dynamically add those jobs and run them for you and tear it all down and record the results when you're done. Likewise, we can use your university's HPC systems, running on Singularity and Slurm. We do that in a number of places. And if you have, let's say, a dedicated AI machine, with GPUs and so on, we can also push those jobs there. But from a reproducibility point of view, the interesting thing about gears is, first, they're totally open. You'll see in a minute, we publish all of our gears as open source. And then the container image itself is designed to support reproducibility. So when we lock down, version 6.0 of our Recon All gear, that gear has all of the code, all of the dependencies in an image that can be invoked, is portable and can be, reproduced in any environment that can run that same container. So it doesn't matter if the versions of code outside of it change, everything is locked down and supports reproducibility. In that context. So it's open in terms of plugging in new gears, and it's reproducible in terms of how we manage those images. Now, if you don't want to process your data inside of Flywheel using gears, we have open APIs for everything, as I said earlier. So where that gets interesting is if you're doing external processing or integrations of various types, maybe with RedCap or similar systems. All of our tools can get data out. You can process it locally, put the results back. The command line tools do that. The scripting language, environments with our software development kits do it. We support the DICOM interface, so you can push data in. You can read data with your favorite tools. And oftentimes, these SDKs and APIs are used in conjunction with Jupyter notebooks and Python and maybe your MATLAB environment if you're a MATLAB user, and you can certainly do it from R as well. So this gives you kind of a flexible capability to just use your existing pipelines that are in place, or to interactively do exploratory development with Flywheel. But again, it's all using common, generally open source tools, and the APIs and interfaces that Flywheel provides makes it easy to do in a very open science way. Along those lines, we also have extensibility built in for data types. So we've got out of the box support for many imaging data types, certainly all the MR data types and CT and PET and many of the common DICOMs. Raw data is supported, and we've seen a lot of other data types, and so we're getting more involved in many different types of data: electrophysiology, digital pathology, genomics, other omics, that kind of thing, EMR data. But if you have some data that we haven't seen before, we have an extensible data type system. So you can, this example here is how we would handle EEG files that we haven't seen before. So we had worked with the Brain Vision folks and they deliver a package of about 3 different files, a header, a data file, and a marker file. And we just simply compose a gear that extracts the metadata and indexes it for search. So now you can, query for all that metadata from a search perspective or export it for analysis, that type of thing. And we also have a viewer plugin framework where we're able to build a waveform viewer for that class of data and register it with the system. So if you see a new type of data that you haven't seen before, you have total control in Flywheel to extend the system to handle the new data types is the point. And as I just alluded to, we have a new viewer extensions API as well. So if you wanted to build a custom viewer for a data type or a specific workflow that you want to do, it's easy to do. But you can also add dashboards at the project level or integrate analytics into your application or your project. And you can essentially attach a viewer at any level of the Flywheel database. So it could be down at the file level, of course, but it could also be all the way up at the project level or a subject specific, view of, for let's say a longitudinal study or something like that. And essentially what this is a JavaScript version of our SDK and some tools that allow you to register your viewer with Flywheel. So again, open extensibility there. Another thing we've done to support kind of open science collaboration is we've recently integrated with several of the leading research federations. So historically with Flywheel, you would just log in through your institutional security, your EDU address, let's say. But what do you do if you have collaborators outside the building and other institutions? And so many institutions would say, well, we need to set up a credential in our system and then send them another ID to use to log in. Now with Flywheel, you can actually if you can allow anybody from any registered domain that's in one of these research federations. So if you have I think there's 4,000, roughly 4,000 institutions on this thing. So if you've got an ORC ID or you're on EduGain or in Common, CI Login, Australian Access Federation, you're essentially, your institution's likely already in this network, and Flywheel can be set up to allow collaborations across, with that kind of, security system already set up. So it streamlines setting up a new multi-center project to enable kind of open collaboration. The other thing I want to address is a lot of times people get concerned about, Flywheel being a platform, from a commercial entity, and they're going to lock us in. We're not going to have access to our data. Just to put that to rest, one thing we have on every project, you'll see this button on the upper right-hand side there, literally a download everything button. Just hit that button, and it'll give you some options here. You can see in this illustration. You can set some filters. You don't have to download everything. But if you want to download everything, literally your entire project, all the work you've done to curate the metadata, all the data you have, everything is, including your analysis, your free surfer runs or HCP runs or whatever it is you're doing. All of that is packaged up and put in an archive for you, so you can easily move it wherever you want to move it. So your Flywheel is completely opposed to any vendor lock-in concepts there. So, and by the way, you also have the SDKs and the APIs and everything I talked about earlier also available to make sure you can get your data out. So anyway, just to be 100% clear and address that directly. The other point is open source. People go, oh, you're a commercial entity. What's your commitment to open source? Everything that touches your data in terms of manipulating your data, that includes de-identification, any of your applications, our gear toolkit, our gear repository, all of that is published as open source. So, you have total control over extending the platform, anything that touches your data. So there never will be a surprise. The only thing that's not open source is our core infrastructure, which, is designed, it's a complex cluster kind of architecture. It scales up, it can handle very large scale deployments, high availability, high reliability, and we just didn't see many people being interested in getting involved in that detail. But all the tools that touch your data are open source in Flywheel. So in that sense, totally open platform. The other thing I'll mention is we're an open source contributor. One of the main areas is our participation with the OHIF community around the viewer technology there. We do some others like Pi.com and various bids apps and things like that our team contribute to all the time. But as an example, we participate in this Open Health Imaging Foundation viewer community. In fact, we contributed the Nifty support to that, and we've also contributed some interesting tools around image annotation, capturing ROIs, and doing blind reader studies to support machine learning applications and things like that. So we're a big believer in open source. We use it, we contribute to it. We publish things in open source. So happy to answer any questions along the way if anybody has any particular questions. On the reuse and sharing side, let's talk about a couple things there. Fundamentally, what our customers are using Flywheel for is essentially to make progress towards the FAIR principles that are discussed in the NIH world. For those of you who may not be familiar, we're talking about making your data findable, accessible, interoperable, and reusable. Now, I won't go through every way we do that. That's a little too much. But broadly speaking, we have very powerful metadata and search capabilities in the tool to make your data findable. We have open APIs and tools. We've discussed many of those already around the accessibility side. Interoperability, from our point of view, comes from picking the right technologies and standards, and we use those wherever possible. And then the reuse side of it, and I'll go into this a little bit more, has to do with really having a kind of an architectural orientation towards sharing of data, but also sharing algorithms. So your project isn't complete if you're just sharing the data. You need to share the data and the algorithms in context in order to be able to reproduce the entire study. And the way we do this really promotes reusability as well. So kind of to touch on that a little bit more, on the data side, a lot of what we do is around, harmonizing metadata, providing powerful search, making, data reusable in that sense. But we also allow you to create new collections and clone data to, for repurposing in new projects. So, a typical example might be doing something like, say, hey, find all T1 weighted structural MR head scans that I want to use for, that I might use for a new machine learning, quality control algorithm or something. And Flywheel can help you do that and, lay your hands on that data, dealing with, finding common or similar images, even though they may not be labeled exactly the same way. On the algorithm side, the complement to that is what we talked about earlier with gears. So these gears are these reusable components that you can plug in. Essentially, they're containerized applications. And but not only do we share the algorithms, but we also have a kind of a systematic way to document how they're being used in terms of processing derivatives. So, when you run a gear in Flywheel, it keeps track of all the inputs, all the outputs, all the configuration options. So you get a fairly extensive provenance on what you've done. So it's really there to help with reproducibility and, reusing, the segmentation runs or other runs that you've done, at which point that obviously becomes data. And then on top of that, we have a gear exchange where we publish all of our gears as open source, and we allow our customers to share them. I'll talk about some examples there where we have some customers starting to share some of their work through our gear exchange. But what that means for you is, you could do something like say, well, hey, find ready to use components, with V4 of the human connectome pipelines, and set them up quickly in my Flywheel system, and then apply them to my data. So they're kind of, we take a lot of the commonly used open source tools that our customers are using. They wrap them as gears. We wrap them as gears. We're not selling the algorithms. We're really just providing a convenience tool to help you run and scale your use of those algorithms. But everything, as I said earlier, in terms of reusability and support for reproducibility of gears is comes down to not only publishing the code and so on as open source, but really locking down those images and making sure that that particular instance of that process can be reproduced and shared as needed.
Travis, there's a
Yes.
question here.
Sure.
Did the researcher clients have ability to use the underlying databases such as Aurora, Redshift, or BigQuery?
Yeah, we have tools that there's a specific feature in Flywheel called data views, which allow you to very easily build a sort of tabular relational projection of any metadata or data that exists in Flywheel and get it prepared to be sent out to any of those kind of analytic tools. So for example, we did a project with Google recently. You may be aware they have something called the Life Sciences API, and Flywheel projects might carry around the genomics files, or VCFs and BAM files, things like that. And of course, we're generating biomarkers and we're carrying other metadata on the subjects. But when it's time to go do that type of analysis, Flywheel can push those views of the data into that kind of a query environment. Kind of a similar thing is we certainly can integrate with external sources. RedCap is one that we integrate with a lot. We're doing some integration with our partners at QuestGen on some new projects there as well, similar kind of EDC data capture tools. So there's a lot of APIs and flexibility for integrating externally, and then we do have this data views concept where you can specify kind of specific projections of your data that integrate with external tools. So let me know if I didn't answer your question well enough. One thing we don't do is, you don't pull out, our system is based on MongoDB because it's very scalable horizontally and vertically. And it gives us the metadata extensibility. Actually, on this slide here, we're talking about, kind of there's a structure for your biomedical projects that's kind of inherently built in, which at one level kind of provides consistency and supports reuse. But every object in this hierarchy can have custom metadata. So we've kind of adopted a NoSQL-based approach. You can attach custom JSON metadata to anything in Flywheel, and then it becomes indexed, it's searchable. Those data views APIs I was just describing can easily access the data and get at it, pull it into a data frame, let's say in Pandas or something. So we went with a MongoDB-based approach. So if the question was implying, oh, can I replace the database with something else? No. Can we integrate with it? Yes. That's essentially the summary there. So we know we don't do every type of analytics possible inside of Flywheel. So we try to connect to as many different environments as you might need. Our strength is going to be in carrying around and organizing, running routine pipelines on your data, making it searchable, reusable, that kind of thing. But anyway, this was the point about the repository design. It provides enough structure to keep you consistent, and then at the same time, it provides a lot of flexibility. So we really haven't run into a use case yet where the customer came back and said, "Oh no, I can't do what I need to do here." The extensibility of the framework is pretty high. Earlier, I mentioned the notion of sharing algorithms. We now have roughly 100 or so gears on our gear exchange. You'll find all the common tools used in neuroimaging. There's, I'd say probably half of the gears are, you can plug them in your application and use them out of the box, and they're commonly used across many customers. The other half of the gears are maybe examples, how to do a certain type of integration or unique data type or something like that. So you can go to Flywheel.io, and if you see on the upper middle part of the menu there's a label that says Exchange. And what this is just really a representation of an open source repository of all the gears that we have. So you'll find which underlying algorithms and the maintainer at that level, but also the source for the gear itself. Good example is our friends at University of Pennsylvania have started contributing a number of gears. In fact, there's an interesting new QSI prep gear that they're going to be presenting in the next day or so. I'll come back to that in just a second. But basically, we have customers sharing gears. We share our gears. It's all open source. And you as a user can certainly build your own gears and plug them into Flywheel for your own needs. And you don't have to share anything. It's totally up to you. And if you do want to share, it's totally up to you when. So Flywheel is not interested in getting your data or getting your algorithms or anything else. We're just trying to provide a framework to help you do your work. and kind of focus on the science rather than the IT side of it. So anyway, it's totally up to you as to whether you want to publish your own algorithms that way, but we have a mechanism for doing it. Let's see, the other big thing for us, especially in the neuro space, is our support for bids. We're a strong believer in, collaborating around data, sharing data, and we've been involved in bids since, day one. And we've integrated bids into the Flywheel workflow. So that addresses a range of issues from starting with import. So if somebody you're collaborating with has data in bids format, or you're working with data from OpenNeuro or whatever, Flywheel's import utilities support bids right out of the box. However, a lot of our customers are using us to curate their data into bids format. So if you're doing work with retrospective data, clinical data, that's labeled however you get it, Flywheel has mechanisms to help you curate that data into bids format, just built into Flywheel. So essentially what it does is it generates all the bids, naming conventions, and so on. And then you'll see here actually in this illustration on the right, there's a switch you can flip. If that metadata exists, that bids view becomes an option, and Flywheel will reorient itself into the folder structure of bids. And just to be clear, Flywheel by default will keep track of all your individual data types sort of as they're captured in time sequence by default. And we can handle any data, so we often handle data types that aren't really addressed by bids. But if you are working in the bids context, you can flip that orientation to be more classification based. So you got a func folder and a DWI folder and NAT folder, that type of thing. So that's what you're seeing here on the right is once the data has been curated into bids, or if it's imported into bids, it'll give you the option to kind of see the time sequence view or the bids orientation. The other thing that we've done in the last year or so is we've implemented support for ReproNim. So if you'll see, Tim Versteenen and John Piles are presenting at HBM their use of Flywheel to create an end-to-end bids imaging center. So they use ReproNim at the scanner, use those naming conventions, and our curation tools are aware of ReproNim, and the data flows in, and you sort of get a lot of you even further simplify your curation of bids. So Maggie Mahan on our team will be presenting a whole detailed, deep dive on our bid support. So I'll leave some details for her. But as you look for that presentation, she goes deep. And then John and Tim are also going deep on how they've deployed bids at CMU. Let's see, the one nice thing about using bids inside of Flywheel is you get the benefits of all of our search tools to find data that you're interested in. And you also get the benefit of the ability to run bids apps and mix and match those with non-bids apps. So on the bids app side, our customers, so we can essentially encapsulate a bids app as a gear and run it as such. So good examples would be MRI-QC, fMRI prep, commonly used, but we have others. I mentioned Matt Sislak at UPenn is announcing a new QSI prep gear, and it's a bids app, but it's also wrapped as a Flywheel gear. And we have a toolkit that helps do that. So if you have anything in bids and that you want to convert into a gear, we make that super easy to kind of connect the Flywheel data structure to the kind of bids app orientation and minimize the amount of work that's required to do that. It would be ideal if it could be 100% automated, but the bids apps tend not to be consistent enough to do that. And then finally, once your data is in bids, of course we have export options for getting your data out in bids. So essentially, the way you can think of it is Flywheel is going to help you organize your work, your collaboration, and so on. It's going to add value on top of what bids can do for you while you're working on it. But in terms of getting data in and out and leveraging tools from the bids world, we treat bids as a first-class citizen in Flywheel, and we're committed to continue to do that. So a couple of presentations, I alluded to these. As I mentioned, Tim Verstinen and John Piles of the Bridge Center at Carnegie Mellon are going to be presenting a poster called A System for Automatic Bids Conversion from the Siemens Console and Flywheel. So what they're saying is, from the console out, bids all the way into Flywheel, and it's an interesting talk. And essentially at the Bridge Center, you have to opt out of bids. Unlike, sometimes you kind of opt in to use bids at other centers. They've standardized the whole center on bids. It's an interesting talk. And then I mentioned Matt Cieslak at UPenn has developed this new QSI, diffusion pipeline. It's all a bids app, but again, it's deployed as a gear. So that's called QSI Prep, a robust and unified workflow for pre-processing and reconstructing the MRI data. So look for that one. And then Maggie Mahan of our team will be giving a presentation, and maybe one of our team members can tell us exactly when that is. But if you want to register for that one, it's going to be in a similar format to what we're doing now. And you could, you can just click that link there and go to Flywheel.io, and there's a registration form. You can get all the details. But she'll be going a lot deeper into exactly how we do it. And essentially there are templates and, some gotchas you got to be careful about. But we've got a lot of experience deploying bids, and Maggie's sort of an expert on all of that.
It's tomorrow at 11:45.
Yeah, thank you, Sina. And then just quickly, one last bit, and I'll wrap it up, and we'll take more questions if you have any. Generally speaking, around reproducibility, and again, we think of reproducibility as sort of fundamental to open science. So reuse and sharing are critical. OpenStack and flexibility and extensibility is critical, but reproducibility is sort of ultimately the goal here. So the way Flywheel works is you always work in the context of a project inside of Flywheel. So you think you go for an IRB approval, you get your project, you put all your data in the project scope, you add the right users with roles and permissions to do what they're supposed to do in that context, and all the code and related executables and so on are also linked to the project. The idea is the project should be a self-contained, reproducible unit of execution. And now you can violate this. If you want to do something outside of Flywheel, you can certainly do it. But generally speaking, best practices would be to put everything together and be able to say this version of this project, has everything needed for execution and reproducibility. And where we're going with all this, and we can do a lot of this today using our gear framework, but we're formalizing more and more of this all the time, is the idea let's say you get to version 1 of your project and you're ready to write your paper. The idea is you should be able to snapshot that entire project, the data, the algorithms, the derivatives, versioned executables, that type of thing, snapshot that, write the paper against that version. And at that point, if somebody wants to come along and clone it to reproduce it, they should be able to do so and be able to, start at the top and run everything. And then obviously if they've gotten that far, maybe they want to enhance or replicate, extend the study with their own algorithms and so on. They've got their own branch, they can do that. And then, we would hope they would in turn, share that, and people can build on each other's work in that way. So not as elegant on that bottom row as we would like it to be just yet, but we're making really good progress towards that. And, you can expect to see, you can do it today, but we've got some things coming that are going to make that, more of an integrated experience in Flywheel. Now that we've got enough customers and people are, we've been at this for 4 or 5 years now, and a lot of the projects that have started up are kind of reaching the point where they're starting to publish, and so this element of Flywheel is now becoming kind of top of mind for us. So that's basically where we are. So I think that's pretty much what I had intended to talk about today. So thank you guys for coming. I hope what you saw there is, we have a lot of open and extensibility features, plugging in your algorithms, accessing from your own tools, building your own pipelines, building your own viewers, extending with new data types, all that stuff. A strong orientation towards reuse, sharing data, sharing algorithms, and so on. And then, ultimately the goal is reproducibility, and we've got a framework that's designed from the bottom up to support, scientific reproducibility. So yes, we're a commercial solution, but we think we're pretty open, and happy to debate that if anybody feels otherwise. But that's how we look at the world, and we pride ourselves on our collaboration with customers, and our job is to provide an infrastructure to help you get your work done and not be in your way. So we want to help you be productive and ultimately deliver, first-class open science, and that's our mission in life. So anyway, I'm happy to stop here and take any additional questions. If we need to, if anybody's interested in staying behind, we could give them more of a product overview and a demo, that kind of thing. But the formal presentation, I think, is at an end here. So Sina or Esther, do we have any additional questions? I'm not able to see the
one other question came through. Open science and crazy developments with AI. Where do you see research 10 years from now?
Well, okay. Okay. That's an interesting one. First off, we're getting involved in many AI projects. Our largest customer is one of the largest pharmas in the world, and they have recognized that the future is in precision care and optimizing, personalizing healthcare. And they see data and AI as the secret sauce, the new thing that's going to make that reasonable and achievable for them. So they've got a very large global deployment using Flywheel to curate all their historical clinical trials data, bringing in real world evidence data, and increasingly partnering with research hospitals and other research institutions to bring in even more data. They see data as the key. So along those lines, machine learning is very important, but ultimately federation is a big deal. You can't copy all data and send it to everybody. Eventually you have to leave the data somewhat, prepare data for research, but more or less leave it in place. So federated training and so on is something we're getting more actively involved in. And then broadly, we don't really talk about this a lot because it's maybe a little far out for some people, but our mission in life is what we think of as cloud scale collaborative science. Our notion is, the data is getting bigger and more complex. The data sets are getting bigger and more complex. Multi-function, cross-disciplinary collaboration is critical to get beyond, kind of traditional rates of success in various areas of study. So if you really look at what Flywheel is doing is, organizing the data, connecting various institutions, connecting collaborators, and with ultimately the goal to, create a whole new modern approach for scientific collaboration. And so over the next 10 years, I don't know, I would probably say, more machine learning, more federation, more advanced scaling. We're starting to work with some of the foundations and NIH around data sharing concepts that, go well beyond what they're doing today with compute in place and other interesting things. So those are early stage, but we would hope to see more systematic sharing and collaboration of data. It's very boutique, kind of ad hoc today in the way we see most people approaching it. So we think there's a big opportunity to change it. Sorry for the long-winded answer there, but it's one of my favorite topics. So anyways, what else do we have, guys? Are we?
No more questions.
Okay. Well, great. Well, thank you guys for coming. What I think we'll do is just kind of open up the Zoom, and if anybody wants to join us, I'm happy to go deeper. If not, again, thank you for coming. Hope you'll see some of the other presentations from our collaborators and customers and our scientific solutions team and so on. Pretty good content there. So again, thank you guys for coming. Esther, what do we need to do to open things up if anybody's interested in just talking for a little bit?
If you'd like to join us, if you navigate to our OHBM booth, there with an open Zoom link to give a meeting. Otherwise, if you'd like to ask a question here, you can raise your hand and we can unmute you or answer any questions. But the best place to reach us would be at that open Zoom link.
Can we just open this up here? Since we've got some people here already? I thought I saw an option to do that earlier.
We can allow everyone to talk. So
yeah, let's just do that. See if anybody has any questions, you know, they'd just like to ask. Well, let us know if, I think you guys are all, let's see, they're still muted. If you wanted to unmute yourself, you certainly could. So we'll hang out for a couple of minutes and see if anybody has any questions. Otherwise, again, thank you for coming. Also happy to give a demo if anybody cares. We'd like to see that. Okay, well, it looks like no takers on that. So as Esther said, you can go to our website and you know, join us. We have kind of exhibitor hours that are open and, you know, for kind of one-on-one conversations or demos and things like that. So, you know, we hope you'll join us for some of that.
Travis, it looks like we have a request to talk about how EEG would work and if there's a possibility to demo how that would work.
Oh yeah, sure. Well, so to us, EEG is just another file type. So let's see, I might have some here actually. Let's see if I can do that. No, that's not where I want to be. Okay, are you guys still seeing my screen or did I stop sharing? Okay. Now I just have to find the instance that has this on there. But if I go to, let's see, this project I know has some EEG on it. So this is what Flywheel looks like. You know, you navigate to your project, you have some number of exams, and in this particular exam, there's a wide array of data types. You know, we've got CTs and PET and, you know, variety of fMRI or of MRI data types and genomics. But here, per the question, we have the EEG, we have an EEG example. And essentially what's happening here is, and I guess the question is whether we run the classifier on this, but we'll find out in a second. Let's see if it has been classified. Of course not. I'll point to another example in a sec. Actually, let me do that quickly because that'll show the whole point. No, wrong one. So, you know, we need to get some, we need to run the classifier on that example in that site. But here, I'll log into Flywheel, I'll go to a different site, and then there's an EEG project that has some EEG data on it. So I'll go here, and you'll see a session that has some data. Now, there's kind of a couple of things that are happening with EEG data. So the first thing we're doing is importing the metadata. So that gets attached to the object as custom metadata in Flywheel. So here we've got the channel info. This is all from the Brain Vision EEG headers. So it's just all the attributes, similar to what we would do with DICOM. We just extract the EEG header data. And then from there, all that's searchable. So, you know, you could do a search and say, I want to find all patients who have a functional scan and a 22 channel EEG. But as an illustration of a custom viewer, you can also work with the waveform data in Flywheel. So this is a custom viewer for that data type, and I'm just adjusting the amplitudes and so on, and I can change the, you know, the time window or, you know, navigate around in this data however I like. And you'll see the markers are along the bottom, the time window is there, and all the channels, of course, on the left. So this would be a way to work with EEG data. the other thing you could do is there are more recent specs around BIDs and EEG and similar data types. Dora Hermes and others have worked on that. And our templating system can easily be extended to do it. We haven't done it ourselves yet, but the framework would work. So you could, incorporate electrophysiology or similar data types into your BID structure if you wanted to do that. So let me know if that answered your question, but this is a good example of a real viewer. And, we've done, in this particular case, brain vision EEG, but the same tools are all available in open source, and we can, help you, incorporate other vendors' variants of EEG or similar data. And by the way, we also support range reads. This is a very geeky thing, but if you have very long, sessions where you're capturing long streams of EEG or similar data, Flywheel can open the first chunk of that and then read in, kind of page around in that data, so we can handle large files of that type by, kind of doing the offset reads and called range reads to make that experience efficient.
Our next question is whether we have a research department.
Yeah, we don't really have a research department in the sense that we're not offering science as a service. So our job is to provide the platform, for use, to manage your projects. And again, I'm happy to do a more comprehensive demo here if that's useful. Let me know. But the point is, we do have a scientific solutions team. So if you're working on a project that needed some help, let's say building a gear or converting a bunch of your data into Flywheel, or building a viewer, or whatever else that you need to do, we have a team of people in what we call our scientific solutions team. And these are all people who are most of them are PhDs in imaging, but also have strong computer science backgrounds. Many have worked in a lab and done this type of work, so they just like what we're doing in Flywheel and help others with it. So we can offer those services, but by default, what we do is teach you how to be self-sufficient. Our primary goal is to have you use the platform, and then we have videos and extensive documentation and so on how to use the platform. So but if on the other hand your schedule's tight or you need some unique expertise or something, we have people who are available to provide those kinds of services. Any other questions?
Someone is asking for a more comprehensive demo.
Sure. Let me just check my schedule and just make sure I'm not running out of time. I have a few more minutes, so I can give a kind of a high-level demo here, and then what I would suggest is maybe we schedule a little bit of additional time for a more comprehensive one. But just to get you the basic orientation of Flywheel, what you're looking at here is that when you first log in, you see your projects, and each project belongs to a group, a lab, a virtual team, that kind of thing. And then you see on the dashboard here, you have some number of subjects have been collected so far. Some number of sessions have been collected. So in a longitudinal study, you might have, of course, many exams per subject. And you would drill into the project in the way I showed just a minute ago. But before I go back and show a little bit more, let me get you oriented on a few things on the left here. So first off, I mentioned gears, these component applications. So this is the catalog of the gears that are installed on this particular system. So, once they're installed, you can run them in batch, you can run them on demand, or you can set up rules to run them. But for example, if I'm trying to find which versions of FreeSurfer I have on here, I can do that. If I want to see that EEG classifier, there's a gear that we just talked about there. The human connectome pipelines, for example, are here. So if you download those from our exchange and put them in the system, they show up here. If you build your own, they show up here. And so that's an important concept. And with that as background, then I'll kind of go a little deeper into what a project might have. So of course you can have some metadata on the project. But then you're typically working with the individual data sets that you're collecting. This view is kind of at the session level, the exam, a trip to the magnet, if you're thinking in terms of an MRI system. But you can flip the orientation to be more longitudinal in nature. So, here I'm on subject 5, and we've got 3 exams we've collected for subject 5 in reverse chronological order. Regardless of how, your orientation is set up, you'll see the same thing. All the details for the exam is on the right, what we call acquisitions. Here's a localizer, here's a scout, here's some, 64 channel bias stuff, spin echo, T1 weighted anatomicals down here, lots of different MRI stuff. Now, what you're seeing is the original data, and these gears are indicating data that have been produced by a gear. And the way that works is those gears can be set up in gear rules and do simple things like, if a DICOM lands, run the classifier, extract the metadata, index it, that type of thing. Once I have data classified, so there's something in the classification field, if it's not non-image data, in other words, if it is image data, it's a neuro project, maybe you'll do the DICOM to NIFTY conversion. You could run MRI QC, you could run your connectome pipelines, kick off FreeSurfer in the same way. It's, so you can set these rules up. And then if you run those data sets, what you'll get on every exam is you'll just get a set of, let's see if we have some here. You'll get a result from each of your various runs. So we've run the diffusion pipeline, we've got all sorts of data here as outputs from that. We've got, let's see, the FreeSurfer run, has the inputs that were used there, all the outputs that were produced, these OBJ files, for example, we've got viewers built in for the, to view those things. Internet connection's a little slow, but anyway, you get the idea. So, you can render those objects. We've got DICOM viewers, NIFTY viewers, all that kind of stuff. But the main point is you have this provenance. So how would you run a gear like, like this? So let's say I'm still on the same data set. I say I want to run, AFQ, let's say. It'll prompt me for some input. I can just pick the file that I want to use. I have all the command options that are available to me. If I know what I'm doing, I could change these values and run it. I can confirm I've got the right version of the gear, go to the source code, everything's open source. But let's say I filled that out and I went to run it. What it'll do is it'll queue up a job here to be executed, and while it's running, it'll have a spinning gear. Eventually it'll resolve to success or fail, and you have the logs and all that stuff. But ultimately what it does is it comes back and produces one of these type of documents to show you exactly what you've run, and which input files you use, which output files you produce, all that kind of thing. So it sort of automates the provenance. So you can start and stop jobs. You can select all of these over here on the left, by the way, and say, batch run FreeSurfer, on those. And, kick off a bunch of jobs, and Flywheel will scale it all up and run it for you. Let's see, another interesting thing about Flywheel, just quickly, because we're going to run out of time here, is the custom metadata. So you can put custom metadata on anything. So in these examples, we have, IQ and other kind of cognitive scores that you might have in a typical cognitive exam, and that's attached to, in this case, the subject under custom info. It could be on the accession, could be on a file, could be wherever you want to attach it. But what's nice about it is you can step up above your project if you want. You can search in a project, but you can also look across all of the data you have access to and search for every one that meets a criteria that you're interested in. So I can jump into search, and I could go in here and say, well, what I want are, MRs for, let's say, females who have a custom, maybe between the ages of, 17 and 100. I'm just filtering, so hopefully that moved. Let's see if it did. Yeah, still got to move it up. There we go. So here's some. And then, and maybe I'm using one of those custom scores. I put a range in. I'll pick a low range just because I don't know what it's in there. And they're all in the same range, so maybe we'll bump that up a bit and see what happens. course, they're all in that range. Let's see if they're, there we go. So you see the search. And we have an advanced mode of search, but I could keep going on this, and you'll see this hierarchy. I got the sessions I've selected, but I could go down even further and say, oh, well, I don't want everything. I just want the diffusion scans. Since we classify everything, it's easy to just say diffusion, and it knows all these different labels mean diffusion. I could come over here to the file level and say, well, my machine learning algorithm I'm selecting data for only takes nifties, so just filter it further down to just the nifties, and now I only have the nifties. And I could select those, and I can download them right now and do my work on my desk or wherever I want to work. Or I could create an ML training set and attach it to a project. Let's say it's that Alzheimer's project, and I want to train on classification, so I can get our internal classification, maybe that IQ score we were looking at. I can snapshot all the labels, so on and so forth. Save it to this file, and now I can use it as input to my machine learning application and so on. So anyway, so that helps you organize your data, helps you organize your processing, helps you organize search. You can annotate everything. I didn't have time to go into image annotation and ROIs, but we have all that. But hopefully that was a kind of a brief demo. I do have to run to my next meeting, but hopefully that was useful. And if you're interested, feel free to schedule some time with us. Sina might be able to stay longer. I don't know if he's got the flexibility to do that.
The best way to schedule a demo is to visit our website, www.flywheel.io, and request a demo through there. I see we have a question about pathology. We're happy to follow up on that now.
Right, sure. Yeah, we are doing some work with several customers on digital pathology. There's a move to standardize digital pathology in the DICOM standards, and we're active in that effort. And we're working with several customers to do that. So we do have some examples in the demo here of digital pathology data, but the real interesting work is what we're doing to take a wide variety of digital pathology file types and make them available as DICOMs, and including be able to render them in the viewer and annotate them and set up workflows in much the same way as you would do with an MR data set. And likewise, EMR data is another data type that we're doing more with. So we've got examples of loading FHIR-based bundles for patients, so you can do everything from claims analysis down to various procedures and medications and correlate those to imaging. So that's another area. But I do have to run, but thank you guys very much for coming and staying this long. Really appreciate it, and hopefully we'll see you again on some more one-on-one time. Thank you very much.
Thank you.